next video is going to be some more stoichiometry stuff, and this time we're going to look at limiting reagents. So remember, limiting reagents occur when there is no excess. So here's the starting question. How many grams of NO2 are made when 250 grams, 250.0 grams, sorry, of N2 react with 250.0 grams of O2. And if you remember from the previous video, we have a process of how we do stoichiometry. Well, we're really just, all that's really to these limiting reagent ones is that you do that process twice. So I'm going to show you what I mean. Remember, first, balance. So it's N2 plus O2 makes NO2. And to balance it, we just put the 2 in front of the O2 and the 2 in front of NO2. 2 N's, 2 N's, 4 O's, 4 O's. Now I'm going to make kind of like a separation here. And we're going to do the calculations for both. For both N2 and O2. So 2 moles known. I have 250.0 grams times N2 is 1 mole over 28 grams, which gives me 8.93 moles. And if I do moles known here, I have 250.0 grams times 1 mole over, oxygen is 32 grams. Should add the equal sign there. And I get 7.81 moles. Slide this over some. Moles needed. 8.93 moles times, if I go back up to here, it's 2 NO2 for every 1 N2. And that gives me, well, 8.93 times 2, 17.86 moles NO2. And if I do moles needed here, 7.81 moles. Now this is the part where you have to be careful. Now I'm looking at O2. So it's 2 NO2 for every 2 O2, which in this case means I get 7.81 moles of O2. Now I can find the mass that I get. And that's 17.86 on this side moles, forgot the units there, times, NO2 is 46 grams per 1 mole, which gives me 821.6 grams. And then on the other side, if I do the mass needed, it's 7.81 moles. Oops, this should be NO2 up here. Times 46 grams for every 1 mole. And I get 359.3 grams. So how much do I actually make? That's going to be this much. Alright, so smaller amount is how much you make. So really, if you had an easy time with the previous video, this stuff won't be that hard for you. It's just you're doing the stuff at least 2 times. Alright, so we're going to do one more example. Now this time, I'm actually not going to number my steps, so I'm just going to go through and do each of the steps for each side. You have to, at this point, you should be able to follow along and figure out what I'm doing at each step. So, if 53 grams of CH4 react with 28 grams of O2, how much CO2 is formed? So here's the reaction. CH4 plus O2 goes to CO2 plus H2O. Now CO2 is the only product I care about in this one, so I can ignore the water. Well, first thing I got to do is balance the reaction. And this one's actually not as hard to balance as you'd think. And there we go, balanced. 1 carbon, 1 carbon, 4 H's, 2 times 2, 4 H's. 2 times 2, 4 oxygens. 2 oxygens there, plus another 2 there. So, now I can set up my little split here. Alright, so I have 53 grams of CH4 times 1 mole for every 16 grams. Why not? I'll add the CH4 in there. And that gives me 3.3 moles. And here for the oxygen, I have 28 grams of O2 times 1 mole O2 for every 32 grams of O2. And I get 0.88 moles of O2. Alright, now I'm going to go to my moles of CO2. So 3.3 mole CH4 times, and it's 1 CO, oops, hold this down a bit so we can get the reaction up there. 1 CO2 for every 1 CH4. So I get 3.3 mole of CO2. Now I'm going to do the same thing for the oxygen. It's 0.88 moles of O2 times, and I get 1 CO2 for every 2 O2. And that gives me 0.44 moles CO2. So those cancel. All right, now I'm going to convert to their masses. Over here I have 3.3 mole CO2 times, and it is 44 grams for every 1 mole, which gives me 145.2 grams. And over here, 0.44 moles of CO2 times 44 grams for every 1 mole, and I end up with 19.4 grams of CO2, which means there's my mass of CO2. Alright, so it looks like that's all. I was just checking my notes really carefully to make sure I didn't miss anything. So that's all for limiting reagents. It's literally doing everything we did in the previous video at least 2 times. So, shouldn't be that hard. Alright, I'll see you in the next ones.